Okay, for this podcast, what I'm going to do is it's dealing with Section 8.5 in our textbook on areas of trapezoids. I'm just going to address question 17. It's the proof. It's kind of a weird one, but it's not too bad. All right, now what we're given, if you look in Sketchpad here, I already drew the figure that they have here, and I labeled the lengths that they've actually given me. So like ED here, I have 8 units. AE is 5 units. FE is 2.5 units. What the proof is, we want to prove that FE here on the left side, so basically the base of this little triangle on the left side, and DC, the base of this triangle on the right side, we want to prove that they're the same. And what we're given is that this big quadrilateral, it's an isosceles trapezoid with AB and CF as my bases, and that AE is perpendicular to both bases, and BD here is perpendicular here too. Alright, now we got to figure out some conclusions though, because the given's the easy part. We just write it, bam, you get some freebie points. Alright, now if we have an isosceles trapezoid, we got to look at what that actually means, because first we got a definition of an isosceles trapezoid, and you look through the theorems and postulate sheets. We've got an isosceles trapezoid theorem. But first start with the definition of isosceles trapezoid. If you look back at it, what an isosceles trapezoid is, it's a trapezoid that has base angles that are the same. And if you look here, our base angles, the ones that we're going to be interested in, because what we want to do is we turn this into triangle congruence proof. We want to prove that these two triangles on the ends are the same. And then if we do that, we could use CPCF to prove these are the same. Alright, now back to our base angles. The base angles that we know are the same are angles F and C here. So, I wish I could make a little mark thing, but I'm just going to do little segments here. We'll say that angle right here is congruent to this angle right here. So those two are the same, and the reason they're the same is because of the definition of an isosceles trapezoid. Okay, so there's an angle. Well, we definitely need more than just one angle to prove that these things are congruent. So if we look back, there's an isosceles trapezoid theorem. What that thing says is that if we got an isosceles trapezoid, we know that our non-base sides always have to be congruent. Well, our non-base sides are AF and BC here. So what I'm going to mark those two congruent. AF, BC. Okay. So now I've got an angle and I got a side, so I need at least another angle or another side. We're still going to work off of the given here though, because in the given they also tell you that AE is perpendicular to FE here. So if AE and FE are perpendicular, I know that sucker's a 90-degree angle. Same thing over here, BD and DC. BD they say is perpendicular to DC. Well, I know that's also 90. So what you could say, well, both of these are 90s, so I know they're congruent, right? Now look what I have marked. I've got two angles in the side over here. I've got two angles in the side over here. So of my main triangle congruence theorems, what you could say is triangle AEF here is congruent to triangle BDC by the angle side congruence theorem, so AAS. Well, you know what? If they're congruent by AAS, then I know that FE and CD, those two sides, the ones we're trying to prove, are congruent by CPCF. So that's generally just kind of walking through the proof. If you want to see what it is written out, here it is in Word. I got kind of lazy. I didn't feel like writing down all the given part from the book, so I just said, you know what, conclusion, write down the stuff from question 17 that's given. And here's my measure of angle F equals measure of angle C by the definition of an isosceles trapezoid. AF equals BC by the isosceles trapezoid theorem. Got my two angles are equal 90 degrees by definition of being perpendicular. Now they got a step in the book that, you know what, if you put it, great. If not, I'm not going to make a big deal about it. Is that you'd say these two angles are equal by substitution. Then we hop into well, I know the two triangles are congruent by AAS, and then FE equals DC by CPCF. Alright, now as for the part B, don't want that, I want this. Okay, they want to know what the area of this trapezoid is. Well, if you remember, area of a trapezoid is 1/2 times the height times the sum of the bases. Well, our height of my trapezoid is 5 units, so well, there's one piece of information, but I need to know how long my bases are. Well, in part A, we proved that F, E, and D, C are the same. So if I know this is 2.5 units, well, you know what, so is this. So the entire length of this bottom is going to be 2.5 plus 8 plus another 2.5, which is 13 units. The top base here, AB, is the other one I need to know for the area formula, is the same length as is from E to D. So this is 8. So my sum of the bases is 8 plus 13, which is 21. So you take 1/2 times 5 times 21, crank out an answer, it's 52.5, and it's 52.5 square units. Wasn't that swell? I thought so.